Alright guys, welcome back. In this video we want to do some practical exercises regarding to broadcast receiver. So this will be pretty amazing. We want to identify them in the Android application. We also want to see what they are doing in the onReceive method. And most importantly, we also want to exploit them. Alrighty? So therefore I would suggest let's dive into this one. Okay, here we are back in the Ubuntu VM and I have prepared two applications for you. Within apps, broadcast receiver, I've got the following two, and I have attached them to the section over here. So you can simply download them. We've got an Android SDK 25 version and an Android SDK 26 version. So this will show the difference between those two major versions. This one is Android 7.1 and this one is Android 8.0. So this means the intent filter in the Android manifest XML will work in this version, but not in this anymore. And this is something we will figure out by doing some practical exercises regarding to this one. Okay, so I mean both versions are identical regarding to the code or the Android manifest XML. There's no difference between SDK 25 and SDK 26. The only difference is that this one has a build version for 25 and this has the build version for Android 8 and higher. That's the only difference. The source code or the Android manifest is absolute identical. Okay, so let's have a look into Android SDK 25, this one over here. Now we're having a little bit of a problem because we do not know how to reconstruct or decode this application right now. I mean with the APK tool, yes, but we haven't learned Smiley so far and we also didn't learn something about reverse engineering those APK files right now. In case if you want to perform this, there's a video within the reversing section, so you can have a look into the JDX-GUI video and then you will be able to reconstruct the code, the Java code, out of this application. Also the code regarding to the Android manifest. So this is like having the source code next to you. I mean, it's not exactly the same source code because this is not possible. It's just an interpretation of the original code, but this is pretty close. I guess it's about 90% or maybe even higher. So you can definitely work with the reconstructed code out of this. Okay? All right. For all others, you do not have to do this, of course. I mean, you do not have to jump 10 videos ahead to perform this task right now. I have also attached the source code to this section. And yeah, I mean, it's simply just a text file. You can have a look into those text files and then you will be also able to figure out what's going on over there. Alrighty? Okay. And this is something we are doing right now. So I've got it already included in my Android Studio, which is over here. And I will show you how you can do this too. Okay, so I guess it has been finished loading. And here we have now the whole IDE regarding to this one. If you want to also include it in this way, what you can do is, because I have now already included it, but you can go into File, New, and then simply Import Project. And then you can select the source code directory and you would end up in the same structure over here. Okay, so the first thing I like to do when I reverse engineer an Android application is having a look in the Android manifest XML, because there's a lot of interesting stuff, and also here. First of all, we are using a permission, and we are using the receive boot completed permission. Alright, we already keep this in mind because this is maybe most of the time or all the time being used in combination with a broadcast receiver. So then we've got this application tag, we can see allow backup true, a lot of unnecessary stuff, but then we've got this receiver tag, and this means we are now having our first broadcast receiver. The name of this one is save data. It's being enabled, and we've got exported equals true, which is pretty interesting because underneath we're having an intent filter. So this one would already set this class to be exported. So this intent filter is performing an implicit exported for this class over here. This is the Java class, by the way, the Android name. This is the code for this broadcast receiver. Okay, now's the question why we're having exported true and this intent filter. And the answer for this one is compatibility. So therefore, we as an attacker do not take care about this one. The developer has to take care about this one. Alrighty, perfect. So now we've got this intent filter. So our application is listening to an event. Which event? This is defined in this action tag. We can see Android intent action battery low. So when the battery is running low, this application will be informed about this event. And this application is going into the Save Data class and reacts to this event. So let's have a look what's inside Save Data. So if we go into this one, here we can see we've got Save Data extends broadcast receiver, and here's our well-famous onReceive method. So this application is listening to this intent, to this battery low intent, and if it receives it, it's executing the code inside here, which is absolutely lame, this code. I mean, it's simply just a print out to the logcat output. Simply just save data, nothing more. But this is perfectly fine, because first we want to have an overview about this whole system, about this construct over here, and then later on I have prepared another broadcast receiver which is performing some actions. So this is now looking a little bit lame, but later on it will be super interestingly amazing. Alrighty? Okay, so far so good. So this is simply just printing out text to the ADB logcat console. Alright, back to this one. What else do we have? Yes, this is all about this receiver. So our receiver is named Save Data. This is the Java class, and we are listening for a battery low event. Okay. Then we've got another receiver, Reset System. Enabled, exported, set to true, okay. Intent filter, and this intent filter is listening to those two actions. First one is boot completed, which requires this permission. So if we are listening to this event but we wouldn't have this permission, then the application wouldn't work. So it would crash or simply not working within the receiver tag over here. So therefore, this intent filter is being tied to this permission. Okay, so now we are listening to an boot completed and a log boot completed. So we are only having two actions right now, because I will run this on a Nexus device, and therefore I guess I would only need this part. In the slides we have seen, we have three actions, but I mean, we do not need to have a huge compatibility if we are running this only on a Nexus device. Okay? Okay. So, and that's all about this one over here. And let's have a look what this code is doing. It's in the class Reset System. So over here, Reset System, oh well, I am that lazy. Another system out print line? Yes, I am. Because as already mentioned, here we want to learn how to trigger those broadcast events. And later on, I have a really nice example for you. Okay? All right. So here we can see if this broadcast will be received by this application, it's simply printing out system reset, nothing more so far. Okay. Back to this one, then we've got an activity, which is in screen content, and this is also the entry point of our application. We can see main and launcher. All right, so far so good. We can see we're having two broadcast receivers so far, Save Data, Reset System. One is reacting to battery low, one is reacting to boot complete. And now I would suggest let's simply install this application and see how we can trigger those events. Let's see how we can actively trigger battery low and boot completed. So let's go. Okay, to install this application, we first need a device. And I recommend using the emulator, because there we can play around with the battery level pretty easily. So I go into my AVD manager over here. And I have prepared a Nexus 6 device. I can highly recommend using this device type, because it doesn't require that many resources, therefore it's faster than the other one, and it also has root access. So this is a pretty neat device over here. So let's start it. Okay, it's being started, and we already get this warning. Emulators running using nested virtualization, so they have to share those resources right now. This is a virtual machine, and this is also running in a virtual machine, which is not a good approach, but it will work for this Nexus device over here. So this is working probably fine. All right, so now we've got our device. Let's enable it. Okay, here we have it. And we can see these are all applications right now. Okay, let's install our app. So we go into this directory, and I'm using the SDK25 version first. So open a new terminal and then ADB install alarm system APK. Okay, back to the emulator. Here we have now this amazing icon. I mean, we've got an APK name alarm system. We've got this alarm icon. So let's see what this application might be. And There we have it. We simply just got an icon and some text over here which claims this alarm system has been disarmed. So the whole functionality of this application is, beside having those two lame broadcast receivers, we are having another one, a more hidden one in this application code. And this one is receiving a broadcast event and triggers an arm and disarm for an alarm system. This could be 100% in real-world applications in the IoT business. Okay, but before we come to this amazing part, let's first play around with those broadcast receivers, with those two. So let's see how we can trigger this event battery low. Within the emulator, this can be easily done. And this is why I really recommend using the emulator, because this is, it's super amazing. If we are opening this one within those three dots, we've got this battery tab over here. And here we can set the battery level of this device. So if we slide this down a little bit, then you can see this battery level is being drained. By doing this, we can easily simulate a device running low on battery. I mean, we also got states like battery health, failed, good, and things like this. So yeah, this emulator has a lot of nice features. If you're running this now on a real device, you might have to wait until your battery level drains low, or until we reach to the point where we actively trigger this event, which is in just a few minutes. But for now, let's keep it this way. Okay, so let's put this over here. Okay, and here we're using now the logcat output to observe this whole behavior. So maybe let's have a quick look once again into the application source code. So here we have the logcat output, and we are now triggering this battery low event, which means our application is listening to this event with this intent filter. And if it receives this event, it goes into the save data class and prints out this text on our ADB logcat console. This is all. All right, let's do this. So maybe let's make this a bit smaller. Yes, I guess this overview is nice. So we are draining the battery, and I'm not 100% sure when this event is being triggered. We can see there's a lot of output already on the logcat. So this might be regarding to broadcast receivers, or could be simply some other output right now. Okay, 50, 40, 30, I guess 20, 10%, something here. Let's see. 20, no, okay. Let's go further. 15, yes, 15. Battery may run out soon. So we get this notification, and perfect, over here we see this. Nice. So this is freaking awesome, right? The smartphone is running low on battery and is sending this event out there to all these applications. And here we can see we react to this event. We are going into our save data class, and we react to this one by printing out, to save those data. I mean, we are not saving these data as a developer right now, but we print them out. So we can see we have application code reacting to an event occurring on the smartphone. Super awesome. All right. Now, okay, this is pretty cool. We can see we can supercharge our smartphone. There we go. And let's trigger it once again. There we have triggered it once again. Does it get triggered underneath a certain level? Doesn't seem like. But if we are reaching this level, so if we are charging our smartphone, and if we go back once again, then we can see it's getting triggered again. Okay, this battery low gets triggered at a battery volume or battery charge of 15%. Okay, cool. Now let's have a look into the other broadcast receiver. Where do we have it? This one, reset system. And here we're having now a little bit of a problem. Triggering and battery low, absolutely no problem in the emulator. But simulating in boot completed, this might be a little bit tricky. Boot completed means after the smartphone has been finished booting, this event will be sent. Okay, we could simply restart this emulator, but then it's not guaranteed that we are attaching at the right moment with our ADB logcat. So this event could be already gone. Therefore, we need to know how to trigger this on our own. And this is super easy in the ADB shell. So let's have a look. Okay, let me put this on. Let's hide this first. Okay, new window, ADB shell. So our friend over here is the activity manager. And if we go to the top, yes, here we've got this broadcast event. And here we can now see if we're using AM broadcast, we can send a broadcast intent. Options are user. We can apply an user ID, we can apply all, or we can say current. And now there is I guess there's some error in here because the description claims and specify which user to send to. So it means we can send this broadcast event to a dedicated user. This user ID, for example. Our applications all have user IDs, so we can simply find them out and send a broadcast event to a single application based on this description. But I guess this is a little bit faulty. So I will show you later on what I mean. Okay, if we are not specifying anything, then it's sending to all users this event. And this is perfectly fine. We as an attacker, we do not take care if we are sending a broadcast event to many applications out there. All we take care about is that our event will be fetched by this application which we want to target. Okay? So we can easily send this to all users out there. That's absolutely no problem. All right, so let's see. Now's the question, how can we send this event? Because here's no action defined. And yes, the action is being defined in the intent help. And this is a little bit annoying, but once you are familiar with this one, it's no problem anymore. So we now know AM broadcast will send a broadcast to all applications. If we are applying all, or if we are applying nothing, then this is the default value. The intent options are at the end. Over here. Oh, a little bit higher. There we have it. The specifications include these flags. And we can see here we have our action flag. Nice. We also got our data URI and our category. So these are those three main blocks. We could also apply a component name. Regarding to activities we have seen, we can trigger a single activity in our application. We provide the package name, so -n, package name, / and then the activity name. This is how we can apply a certain component. We could also do this over here, maybe regarding to this one, save data, for example. But I mean, we do not have to target a certain component name. It also doesn't mean, I guess, that it's being sent to a single application out there. And therefore, we do not get an advantage right now. We could make a mistake regarding to this name, and therefore we are not applying this in our command. Okay, so what we need to do is maybe a little bit smaller. It was really large. All right, so let's get our puzzle together. What we need to do is we need to call AM broadcast and then our action -a. What's the action name? Well, let's see. Over here, let's call this part boot completed. So within this action tag, we've got this name. And yeah, we simply copy this part. All right, now let's open the logcat on the right. And let's see, we should see right now, sorry for the jumping, but we need to figure out what we are looking for. So within our application, we are looking for this event. And if this occurs, we go into the reset system. And within the reset system, we go into the on receive. And then we are printing out some lame text. Perfect. Let's see. I'm executing this in 3, 2, 1. And we're getting an error. What's the error? Permission deny, not allowed to send broadcast Android intent action boot completed from PID and the UID 2000. If you're performing an ID, we can see we are having the user ID 2000, which is the ADB shell. And the ADB shell is not allowed to send and boot completed broadcast. All right, this is unfortunate, but we've gotten workaround. So we simply type in SU and then we are having root privileges. And the root user will be definitely able to send this command. So let's see. AM broadcast -a, this action. I'm hitting this in 3, 2, 1, and let's have a close look to the logcat. 3, 2, 1. All right, there's a lot of stuff going on, and like I would have made it in this way, our system reset is on top of it. So pretty nice, right? Absolutely. So we can see we are triggering this event actively right now. We do not have to wait until the smartphone reboots. We are triggering this event, Android intent action boot completed. So those applications think right now that the system has been rebooted, and this could be a little bit messy because those applications are reacting to this event and they might think, okay, the smartphone has now finished booting. I have to start a lot of stuff, which we can see over here. There's a lot of things going on and it might be not wise to do this on real smartphones. I guess you do not break something, but yes. I mean, in an emulator, we are probably safe. Okay, let's see how often we can do this until something crashes. No, maybe not, but I mean, we could simply repeat this step now over and over again. And we can see our application is reacting to this one, like shown over here. So this is how we can actively send and broadcast. And so far, so good. All we need to do is we need to use am broadcast-a and then the action name. We can find the action name in the Android manifest XML over here. Okay, perfect. Now let me show you what I mean with this user type. So let's make this larger. Let's leave the root context and let's use am once again. Okay, if we go upwards to broadcast, where do we have it? Over here. So the description claims that we can use am broadcast with an user -- user and an user ID. And it claims that it specifies which user to send to. If not specified, then send to all users. Okay, so based on this description, if I read it correctly, we would send this broadcast event only to the single user, to the single application with this user ID. How can we find out the user ID of our application? Well, this is super easy. If we go back into this one and using PM, the package manager, and then going upwards, there is something like PM list packages. And here we've got this option -U. Also show the package UID. So if we are performing PM list packages -U, then we are listing all those applications with the given user ID. And let's do this. PM list packages -U. Nice. So here we have now all apps and we've got the corresponding user ID at the end. Now I do not want to search through all of them, so I'm simply grabbing for app hacking because this is why we are here. And here we have our app hacking broadcast receiver with the user ID 10,124. Let's verify this. If we are getting root privileges and if we go into data, and if we are performing ls-some options on app hacking, so we're grabbing app hacking, then we can see we've got our application and this one has the user ID A124. This A can be replaced with 10 because it's being 10,000 from the user ID where our applications start counting from this ID, which means we are having the user ID 10,124, which aligns with this one. Perfect. So now we've got everything together. Let's try sending this broadcast event to this user ID. So we are using am broadcast --user 10,124 and then our action. The action we are getting from here. Okay. And this is the whole command. Okay. Or maybe let's do it this way. All right. So let's restart the loghead. This means we are now sending this action to this user application. This is our user application, so the alarm system application, which means we should only see this log output over here. Reset system, system reset. This is the only log output we should see on our terminal, right? At least this is my interpretation of this whole stuff. So let me show you what happens. We can see skipping broadcast intent, a user, this one, and if parent are stopped. This one is hanging right now, which I have no explanation for this one. But we cannot see any output. So the broadcast seems not to be successful right now. And to be honest, this -- user command is being used also in other commands, but in a different way. If we are typing in the activity manager once again, and if we go upwards, let's see, over here, for example, in the start activity, specify which user to run as. And I guess we read this quite often. And this is also my interpretation of this one. So I guess the description over here is simply false. And so what I have observed so far is if we apply this -- user, this is the user that executes this broadcast command. Let me show you this. I mean, this is not required right now, but in case if you try to send this to a dedicated application and you are relying on this one, then you might spend quite a lot of time with this. Okay, so if you're using AM broadcast -- user 10,124, I guess this was the user ID. Let's see. Yes, that's the user ID -a, and this is our command. If we're now executing this, we are getting the same behavior, okay? So we are not even getting that the current user has not the permission to do this. Okay. But now, to show you that this one might be the current user ID, we're simply using the user ID 0, so that's not the dedicated application user ID. We try to execute this as user 0, which is root. And we're not having the permission, of course, to do this. So let's see. Yes, we're getting a permission denied because we're not allowed to send this broadcast from the user ID 2000 as the user 0. Last but not least, let's do this once again, but this time with root privileges. And this time we are not claiming to send this to this application. We are claiming that we are sending it as the user ID 0, which is, maybe let's do this once again. Here we can see, this is our user ID. Okay, so this command over here. And now let's observe the logcat output. 3 to 1. Oh, interesting, right? So here we can see we've got the system reset, all the other broadcast events related to this one. But yeah, I guess this is simply just an error in the description. So please do not spend some time sending it to a dedicated application based on this one over here. Simply go for the try hard approach. Send it to all applications. The only thing we are interested in right now is that our application fetches this event. All right? This is the only important thing. If you're sending out this event to other applications, we simply do not care about this one. This application needs to receive this broadcast event. Alrighty. So far so good. We have seen two absolutely lame broadcast receivers. Let's have a look back. And here, this is all we have in the Android manifest XML. We can see Android build version SDK 25, so Android build version 7.1. We can use those receiver in the Android manifest. Okay. In this application code, there's now another broadcast receiver, and this might be missed by automatic tools right now. So automatic tools might rely on the Android manifest XML to identify those broadcast receiver, and they might miss the following one. We only are having this one class main activity left, because these are all our three classes. We have seen reset system, save data. So now let's have a look into the main activity. And well, what do we have here? Let's see. Register receiver. So this is now the Java code approach regarding to broadcast receiver, which is required for Android 8 and higher. It will also work for Android 7, of course, but it won't work vice versa. So this approach doesn't work anymore in newer versions. This one will work in all. And this is why we are also talking about this one, because you need to be prepared for things like this. Okay, it isn't that hard. I mean, it's simply just a transformation of our code. So here we can see Within the onCreate method of our main activity, we are having this register receiver. This is now our receiver we want to register. So this is our name of the receiver, alarm system receiver. Then we are having in parameter new intent filter, and this one is now the action. So this is equivalent to this one over here, and also this one over here. Okay, we get an error because that's not in class right now, but this is the equivalent if we are having this in our Android manifest. All right? Okay, let's undo this real quick. There we go. So now we are registering the alarm system receiver and we are listening for this action. This is now a custom action. We can see this on the package name already. And let's see what this custom action is doing. All we need to do is we need to look into the onReceive method. And now's the question, where is this onReceive method? Because we cannot see it anyway. And this is regarding to this IDE. I do not know why, but if we click on this one, is it working? Then yes, then we get this whole context. So I was also searching quite a while until I figured out, well, it just have been overlapped over here. Okay, so now we've got the onReceive method and then we've got everything together. We've got our broadcast receiver name, we've got the action, and here's the onReceive method. So let's see what's being doing. So let's have a look what's happening over here. Okay, we've got this time a variable name, so no system out and then leaving. This time we are having a variable name and now it's getting spicy. This variable name will be assigned with the things we add to our broadcast. So our broadcast is taking some additional information in an intent. So we can apply a string to our broadcast event. And the string is being based on a key value pair. This one over here is the key. So we have to apply an intent with the key status, and then this status, this value of the status will be stored in the alarm state. In the line underneath, we can see this alarm state will be compared against arm. So if the string is arm. So this means our key value pair needs to look the following. We need to apply a key status with the string arm, and then we would end up in this if statement over here. All right? Don't worry, we will do this afterwards and you will see this is super easy to do. Okay, so within here we can see we are setting this text, we are setting another image resource, and we are printing out some text. So here we would arm the alarm system right now based on a broadcast event, which is absolutely amazing. What else do we have? If the state is not arm, if the state is disarm, then we are performing in disarm of the alarm system, all right? And in case if everything is unclear, because we are neither having arm nor disarm, then we have in status unknown. So here we can see we can execute or trigger certain parts in our application code based on the things we provide to this intent. This intent can be triggered by any application right now because it's not using a certain permission. There isn't a permission defined in the Android manifest XML regarding to this one. And there's also no certain permission defined over here. So an attacker could write its own malicious application and trigger this event from the attacking application. So we can arm and disarm a system, as we have seen so far. The only downside for this one is the application needs to run. Why? Because if the application gets started, we are starting the main activity, and this is our entry point, and this one over here. And this main activity is calling the onCreate method, and this onCreate method is calling or registering this intent filter. If the application is not running, we are not having an intent filter being registered, which means we cannot interact with this broadcast receiver, because it simply doesn't listen to our events. This is the only downside right now, but imagine having an alarm system application which could be armed and disarmed via a malicious application. Absolutely amazing, right? Absolutely. So let's do this over here. Okay, let's see how we can apply certain information to our intent. Okay, so therefore we need to have normal privileges. We do not require root privileges anymore. And then within the Within the AM, we've got this intent section over here. We have already seen this -a, and here we have now all these extra key, extra string values. So here we can see extra key, extra string, extra boolean, extra int, extra long. All we need to do is apply --es, and then we can append our information into this broadcast event. So we can simply say am broadcast -a, the action name. We fetch this out of here. All right. And then --es status. This is our key. The key can be fetched out of this one over here. Intent get string extra. So this is something you definitely need to look for. If you're having an onReceive method and there's something like intent get string integer boolean, then have a look into this one, what happens with this state. And then we can apply a value, for example, hacked. Okay, let's open the ADB logcat, also the emulator. And now let's execute this. And here we go, status unknown. Nice, maybe a little bit larger. Yes, here we have it, alarm state status unknown. So we have now triggered this code path based on our broadcast event. Freaking awesome. So we need to analyze the application code, what happens with our input, because this is where vulnerability can occur. Unfortunately, we cannot simply tell that having a broadcast receiver and providing some information to this one is a vulnerability. We have to see what could be triggered. In this case, it seems to be pretty spicy because we have things like ARM and this ARM. But first, let me show you some other stuff. If we go back to our smartphone, and if you're repeating this command and if you're not providing any intent, so we're simply just calling this broadcast event, then let's see what happens. A 3, 2, 1. Okay. Oh, and there we go. The application has been crashed, and we can also observe this in the ADB logcat output. So let's scroll up, and here we have it. Broadcast receiver alarm state. Yes, this sounds like us right now. So we have crashed this application, and the problem is null pointer exception. Attempt to invoke virtual method boolean on and Java string equal. So let's see. All right. So what we are doing over here is we are fetching the value from our status. So in this case, we are not having anything in here because we did not provide this intent. We are fetching this value into alarm state, and this is now being assigned to null. So it's not even assigned, it's simply having a null state. And then we are performing an alarm state equals arm. So we are performing null equals arm, which will cause an exception because, I mean, we are not having something like null equals. Based on the Smiley code, we would have some registers which are being compared, and those register, one of them is being null, which will throw an exception because this cannot be correct anymore. All right. This means if we're dealing with broadcast events, I mean, we also have to take care of what we are inserting and that we are being compliant with the code. Otherwise, we could crash the application, which might be also an absolute valid use case to crash a certain application. But right now, we do not want to crash this. We want to interact with this application. And now it's getting spicy. So let's try to arm and disarm the system based on a broadcast event. Are you ready for this one? Let's do this. Okay, we start with arm. So we have our status, our key status, and we want to apply the string arm. Let's do this. Let me give me some more space over here. Okay, logcat is running. Smartphone is, oh, we need to restart this application first, otherwise it wouldn't react to our event. Okay, and now am broadcast -a alarm state -es status. I'm not sure if we need those quotes. It might work also without them. Okay, our key is status and our value is arm. Let's do this in 3, 2, 1. Nice. We have armed this alarm system based on broadcast event. Pretty amazing. Let's disarm this alarm system. So instead of arm, let's call it disarm. 3 to 1. Oh, well, now we have disarmed the system. So this is how we can tamper around with broadcast events. We can also see this notification alarm system disarmed. All we need to do is we need to have a look into the Android manifest XML or the Java code. It depends on the build SDK version, and then figuring out what's the action name and what happens in the onReceive method. These are our steps to play around with broadcast receivers. And this is pretty nice because developers often underestimate the functionalities or the trouble a broadcast receiver can cause in the application. They are most of the time, barely all the time, being exported to the outside world. And as an attacker, we simply have to take a look into the onReceive method. This is all we need to do, and yeah, to figure out what we can tamper with this broadcast event. Alrighty? Okay, last but not least, let's have a quick look what happens if we try to trigger this broadcast event, which has been defined in the Android manifest XML, but the Android build version is Android 8 and higher. So let's see what kind of error message we get, because then we know what we need to look for if something is not working anymore. So, and therefore, let's go into the Android SDK 26. The code is identical, so just the target version has been changed. Okay. And now let's start this one. Let's open the ADB logcat. Maybe let's clear the logcat output, but I guess it will be, yeah, okay, it will be full anyway. So here we have now this application. I mean, this approach still works because this is being defined in the Java code. This is compatible to newer and also older versions. This is absolutely fine, this one over here. But if we now want to trigger, for example, the boot completed command, let's see. Okay, am broadcast-a. So over here, this one. And let's see what kind of error we get. Or maybe let's do this with the battery first. Yes. Okay, let's charge our phone up. Bam, there we go. And now let's lower the battery. Okay, so now let's take a careful look onto this one. All right. We cannot see our text anymore. Let's enlarge this. So there's no system out regarding to the batteries is being low. And here we can see, yes, background execution not allowed, receiving intent within safe data. So this one is not working anymore. So if you encounter things like this, background execution not allowed, it's not the problem regarding to your setup or the actions you try to trigger. This is regarding to that the Android version is too high right now. So the developer has not updated the code in the Android manifest regarding to this one. And to be honest, this is something that can easily happen. But now you know, if you see this, then you do not have to search for a bug in your code or in your setup. It is regarding to the application itself. Alrighty, maybe one last proof. Let's trigger this boot complete action with root privileges. First, let's charge the phone. Okay, it would be nice if this would work in real time. So ADB logcat, am broadcast-a, and then, yes, I still got it. Okay, 3 to 1. All right, we can see the other applications are reacting to this event, but in between those log messages, yes, this is, okay, this is something we have to do it differently. We are searching for app hacking. There we go. Yes, let's trigger this once again. Yes, here we can see background execution not allowed. So the Android manifest approach doesn't work anymore. Absolutely no problem. Then we know we have to look into the Java code for those additional broadcast receivers. Like this one. I mean, either way, we definitely have to look into the Java source code and look for those onReceive methods. So now we know how to deal with this. And this is why we are here, right? So if you're having tools that cannot perform this task, absolutely no problem. We know exactly what's going on. We've got the background information regarding to this one. And if we have to identify broadcast receiver, at least after the reversing section, we will be able to do this by ourselves. And then we do not miss anything in this application. Alrighty? Okay, so this is all regarding to Broadcast Receiver. Have a look into the Android manifest. Also take a look into the Java source code, if we have talked about this one in the onReceive method. And then, it depends on the code that's being stored in there. In this case, we can trigger an arm and disarm command based on broadcast event, which is absolutely dangerous. Sometimes you have some really nice things inside here, and sometimes, even by triggering them, it's not a big deal, like those two lame functions. Alrighty? Okay. So in case if you have any questions, please drop them in the comment section under this video. I will definitely answer them. Otherwise, I hope you had a lot of fun and I'm really looking forward to see you in the next video.